So you ready to move on?
Yes, sir. That was
I think Admiral
fantastic.
Becker is up next, is he not?
Yes, we're going to bring back our good friend Paul,
Yes, yes,
and he's going to make some introductions, and he's going to moderate a discussion.
yes, he is. Yes, he is. So we'll take it away. Is he there? Is he there?
I'm
I
here.
think
As soon
he
as
is
my
here.
video is
Yes.
activated,
It was
I'll
kind of
be
tough to
ready
see on our screen at first. Well, you having a good day so far?
yeah, this has been stimulating.
It has. I just wondered if you had a chance to be a part of it and see what's going on thus far.
Almost all of it. I
good
was
for you.
suspect at first, a full day on Zoom. I haven't done that since the outbreak of pandemic. But so many topics were of interest that I just stayed tuned. But this is one that you'll really want to pay attention to. We're the penultimate event, and it's a panel of 3 renowns. We'll be talking about tomorrow's space needs. And along with me are former Air Force General Gene Renaurt, Dr. Barry Kirkendall, and Mr. Jason Kim. And if I could please bring them on the video as well, I'd like to give a brief introduction for each of them. And then after the introductions, gentlemen, I'd ask you to provide an opening comment, and then we'll get into group discussions. And I'll go in the order of General Renaurt and Dr. Kirkendall, and then Mr. Kim, if that's okay with everybody. Super. General Renaurt, a former Air Force officer. He commanded U.S. Northern Command and North American Aerospace Defense Command in the day. He knows a lot about strategy, policy, and plans because he was the director of strategy, policy, and plans for our Joint Chiefs of Staff. And while, like many Air Force officers, he likes to spend time in the mountains of Colorado, we know his favorite tour was in Hawaii when he was the vice commander of the Pacific Air Forces, because there's lots of palm trees, oceans, and ships, and the Pacific Fleet right there. So welcome, General Renaurt. Good to see you again. Dr. Kirkendall is the Defense Innovation Unit's Director for Space. Small portfolio, right? Hubs in Mountain Home, California. He is an expert in modeling and simulation and deep background in everything from electrical engineering to physics. And we look forward to his comments as well. And Mr. Jason Kim, also a former Air Force officer. He is the CEO of Millennium Space Systems, and he's hubbed out of that space ecosystem around greater LAX, El Segundo, I believe, Jason. Jason cut his chops as an Air Force officer, but it's also made his mark in the corporate sector with some significant accomplishments with Raytheon and Northrop Grumman before coming to Millennium Space Systems, where he is now. With that as an introduction, General Renaurt, hand over to you. You're a director at Kymeta. Please tell us about that and how that relates to our topic today of tomorrow's space needs. Nothing heard. We'll keep working that. Dr. Kirkendall, would you mind kicking us off? Tell us a little about what's going on with the space portfolio at Defense Innovation Unit.
Well, thanks for the invitation, Paul. It's a real pleasure to be here. In the physics world, we don't have too many of these types of panel discussions, so it's a pleasure. I think in the space defense portfolio at DIU, to be fair, I'm the technical director. General Butow is the director, and Mike Brown runs DIU itself. So I would say that at DIU, I'm on a sabbatical from Lawrence Livermore National Lab. I've been here for about 8 months. And one of the greatest things that I've noticed is the mix of commercial investment for signaling that the government makes. And so, I'll talk about some case studies of this today. Nuclear power and propulsion is a great example. Possibly hybrid space architectures, architectures of the future. But just this idea for every dollar that we're putting in to a company, that's messaging the commercial markets to match over $40. So these are small and non-traditional companies. So the idea here is that, if we just pay attention to what commercial is doing, don't try to change them, but try to get what we need out of that and make our needs sort of fit into those architectures. That's a real win. And it's not a check for the government, it's a leveraged investment. And I think that's one of the coolest things I've seen since I've been at DIU. Again, it's a real pleasure to be here. Looking forward to the discussion today. I'll turn it back to you.
Thanks, Barry. Hello, Jason. Will you take it over next, please?
Hi, Admiral. Thank you for the introduction. Can you hear me okay? Awesome. Thank you. First of all, happy birthday to the Marines, and happy Veterans Day tomorrow. As you said, I was a former Air Force officer and wear that proudly on my lapel, and I still bleed blue. And it's one of the reasons why I'm still in this industry, to give back to our nation. And I was thinking about what you had us on tap for today, Admiral Becker, and there's so many topics we could cover, but what I'll focus on is the technology and approaches that will keep us ahead of the curve. And at Millennium Space Systems, our driver is our customers' missions. They need solutions and they need them fast. And so we've designed our company to move fast. And anything that's going to help us drastically improve production, schedule, and cost for our customers, that's what we're focused on. And that's particularly important in an area we lead in for small satellites. That's national security space. A lot of the work we've been doing has positioned us to be nimble, because the threats are advancing, and they're here now, and they're only going to continue to advance. So, what can we do to get the new capabilities on orbit faster for our customers? You talk to the COCOMs, they want the capability now. One way we believe will help to do that is additive manufacturing. I see that as a next big evolution in satellite production, and we're doing it today. You may know that we flew a 3D printed satellite with a polymer back in 2017, and working with our parent company, Boeing, we just recently flight qualified an all metal aluminum and titanium half ESPA class satellite, which we anticipate flying in the near future. The other thing I'll mention is that the future of ground operations, ground operations architecture for small satellites will more than likely be a hybrid ground and on-orbit processing future, as well as having autonomy built in. And that's going to reduce not only cost, but also latency, and it will also move us towards a more automated lights out mission operations where very few humans need to be in the loop, and you just operate that much faster. So at the end of the day, our focus is responsibly delivering to our customer's mission. The mission dictates the capability, and when it comes to national security space, that's where we're focused on delivering the right performance for the best value. So thank you for having me on the panel.
Super, Jason. Thank you. Let's just continue until General Renaurt joins us. A question for both of you. Start with Barry. Barry, what can the government side, learn from the commercial space sector and apply to what we're doing at Defense Innovation Unit, or broader than that? Through the course of the day, there was Space Forces and Space Command that talked, and interested in your perspective as well.
Well, there's, I've spent a long career at Livermore and moving over to the DoD now, and clearly there are a lot of ways that they do work in the government. The thing about commercial is, and Jason, you probably know this, or you do know this better than I do, but the government should see commercial as a partner, and just what they're making. Try to purchase what they're making. Don't try to change the company. Don't try to change anything about that. Try to fit those products more cleanly into the things that we need. So, for example, if you wanted to have a space internet, just for example, there are companies that are forming space internet. And so instead of making our own space internet, why don't we take a company that's already making one, find out what that architecture is, plan out how our needs, the DoD needs, might fit in that architecture, and then build on that. And I could talk a long time about nuclear power and propulsion. I'm a big fan of that. And I would say that there are some great efforts happening within the government now. I mean, I see Project Draco, which is nuclear thermal propulsion, that's coming out of DARPA. And I see Project Pele, that's the Strategic Capabilities Office of the Office of Secretary of Defense. That's a compact fission reactor. NASA's got some great work on that. But I say that for nuclear power and propulsion, there is so much more than those larger reactors and studies. There's a lot of work in the commercial area, commercial nexus on fusion, enabling fusion technologies and radiological materials. So more advanced plutonium sources that aren't plutonium are easier to launch. They may have a much shorter life, but they have a higher output. So I could talk into detail on that, but when you look at those commercial nexus for the fusion and the radiological materials, I think we need to really pay attention to what's out there commercially. I think it have a huge effect on the future space needs. And, I think I could talk all day, but I see a lot of pressure for where nuclear might come in. And I think I'll save that if we do get around to nuclear. But from the time that I've had it at Defense Innovation Unit, that's really one of the key takeaways that I'm paying attention to is just learn what these companies are making, understand their investors, understand where they're trying to go, and don't try to disrupt their commercial plan. Just take what they have and then run with it. So that's my initial thought on that, Admiral.
Hey, thank you, Dr. Kirkendall, and welcome, General Renaurt. How are you, sir?
Fine. I guess in this great space age, my fat fingers and my computer weren't talking to the rest of the world, but I apologize for just now jumping on.
Well, you know what happens when you're the last one into the ready room. You're elected the mesh treasurer for next month, so we'll send you our menu selections. Thank you, sir. I already provided an introduction, and I mentioned that you were a director with Kymeta, but I didn't mention what Kymeta does and how it's addressing tomorrow's space needs, the title of our panel. Would you please start there, sir, and then we'll just fold you into the conversation.
Great. Thanks, Paul. I appreciate it. I joined the board of directors at Kymeta a little over about a year and a half ago. And Kymeta is really a leading edge satellite communications antenna innovator. We've built a unique flat panel phased array, electronically scanned array antenna that can really create new opportunities for especially communications on the move and comms on the pause for our deployed folks and law enforcement and the like. A great science and research team that has done a lot of great work in metamaterials and how to integrate those into the antenna process, and right at the leading edge of the next generation of antenna capabilities. So I really became excited about the opportunity that this technology might bring, certainly to our deployed military, but to really anyone who requires very high volume, very lightweight size, weight, and power requirements, and very mobile satellite downlink capability. We've tested this on vehicles on a 27 or 800 mile drive. We've taken them to the top of Pikes Peak. We've taken them into the base of Death Valley. We've had them deployed forward into Afghanistan and with a couple 50 caliber rounds through the antenna, and it keeps ticking. We've rolled the antenna over on a couple different vehicles, and it was able to maintain power and immediately pick lock back up. We've had them in sea state 4 and 40 knots on the water, and the only way you could get it to break lock was to drive underneath the Chesapeake Bay Bridge to break the lock physically. So it's a really great capability, and when you put it against the other systems out there that are trying to tie to the really proliferated constellations that we're going to see in LEO, and then the very high data rate capability that we see in geo orbits today, it really is going to change the way we think about satellite communication. So I've been really excited to be a part of that. And I think I was really pleased to see Kymeta being named one of the top 10 new space innovations at a recent symposium. The Space Symposium in Colorado Springs did a lot of really, really great work in terms of highlighting the Kymeta capabilities. And the company's really moving out rapidly to develop new markets with some great partnerships from many of the LEO constellation operators.
Super. Thanks, General. The question you rolled in on when Dr. Kirkendall was speaking was, from a government perspective, what did he see that the commercial sector was doing right? That the government should pay attention to. Let me roll that over to the commercial sector. And Jason, do you have a perspective on that as well?
I do. I appreciate the question. Industry is learning how to become fully digital right now. And Boeing is a perfect example. They've been doing it for a while on their airborne programs and now their space programs. So right now it seems like a lot of the digital engineering is being done in pockets, and like a digital model to support simulation analysis, but the digital thread end to end does not extend all the way necessarily for some of the space programs through a program's lifetime, from design, manufacturing, and on-orbit operations. That's the future. We want to have that digital thread end to end. And we've heard General Raymond talk about building a digital engineering ecosystem, and that's what we're embracing right now. And we're working toward what I call a digitally defined small satellite company here at Millennium Space Systems. And so the future vision is working toward a true digital thread throughout a satellite's lifetime, whether it's a prototype or a constellation, from those digital twins to 3D printing the structure to putting all the open system architecture components together, and then manufacturing, testing your vehicles, launching them. And then that's all through a digitally defined assembly line. I think there's a lot of things that the industry is doing right now as proof points to that digital future that the Space Force and other government organizations can learn from. So if you have that open dialogue, you share the SysML formats and language, and you share the actual models. We've heard a lot in the press about what the Space Warfare Analysis Center is doing for the Space Force right now, the SWAC, and how everybody's embracing that. I think that's a perfect example of where the government can learn a lot from what industry is doing and experimenting with, and actually not just experimenting, but operationalizing. That's an area that I think would provide a lot of value, because if you do that upfront, systems engineering and engineering design, it's the old adage, you measure twice and you cut once, right? Everything in the back end of manufacturing becomes smoother, faster, more efficient, and then we can turn that into schedule savings and deliver full constellation systems much faster to the COCOMs.
Thanks, Jason. General, if I could shift just a bit. A common phrase in the Department of Defense and the interagency process is allies and partners. We're better with allies and partners. How does that apply to tomorrow's space needs? You're in the commercial sector now. If you could address it from that perspective, and then I'll go to Barry from a government perspective. Is too much proprietary, should it be, intellectual property, or should we explore allied and partner equivalents in commercial space needs?
Well, that's a great segue into a really long conversation, but I'll try to make some succinct points. And Jason mentioned my good friend Jay Raymond. General Raymond talks specifically about the value of our coalition partners and friends, not just formal coalition partners, but friends around the world who have great capabilities in a variety of space areas, from satellite system operators to launch vehicle producers, really to the very fine-tuned capabilities that you could put on very small satellites and proliferate them in a variety of different locations in orbit. And so we, the US, I think, can't afford to go it alone, if you will. Certainly, there was a period of time when we were the preeminent force in space and of space. But today we see nations as small as Vietnam with a satellite capability on orbit. And so we need to understand where we can partner with our friends, take advantage of the agility that the commercial sector brings to this. A number of people chuckled when Elon Musk started SpaceX and was beginning the launch business, and our NASA folks and our Air Force launch folks said, "Oh, he hasn't learned all the lessons we've learned, and so he wants to jump right over those." Well, in fact, what he did is he really learned them quickly. He understood that what NASA and the Air Force had spent truly decades, and for good reasons, developing in terms of the dynamics of space launch, in terms of the safety in space launch, that data was immediately available to Elon as he began to put together SpaceX. Why go back and recreate that again? Well, we need to be the same way now as we look at innovation in space, and especially what our partners bring in terms of innovation in space. And I know General Raymond is looking to create a forum with our friends and allies around the world to talk about the things in and of space so that we can take advantage of that. I think it also gives us the added security of knowing that as we create more of a broad network in space, that those who might be near peers or even competitors, and hopefully not, but potentially adversaries in space, have to take pause if the network that the United States is a part of with our friends around the world is so strong that it makes challenging in space a less palatable option for a nation to take.
Thanks, sir. Hey, Barry, over to you. And if you could, are there any beyond our traditional Five Eye partners? Right? Are there any countries where you could highlight that we have a particularly good relationship with for tomorrow's space needs?
Yeah, Admiral, I mean, I love this question. Before I took this position, I was one of the liaisons to the U.S., to the United Kingdom U.S. 1958 Mutual Defense Agreement. And so I spent a lot of time with our allies over in the UK, and just the effect on our deterrence posture had huge benefits. So I'm a big fan of our allied nations for that deterrence and just the coalition. And I believe that science and technology is really a great place to work on those relationships, because as a scientist, I can tell you, as a 25-year-old scientist that went to, say, Venezuela or South Korea, that was an exciting time to meet your counterparts. You have a lot of great ideas. It's a fertile ground to get S&T involved to kind of push these allied projects. Admiral, you mentioned beyond Five Eyes. I would say for space, Japan is a critical ally, France and Germany. And I'm not limiting to those countries, but let me give an example. I've actually been trying to push a radiation sensor proposal to Five Eyes. And the idea here is that we don't know what the radiation fields are in general beyond LEO. And it's not, we know what the averages are, but it's the spikes that are going to kill you. And we really can't predict those spikes. The physics-based models are not sufficient to give us what we need, so we need data. So the idea here is, look, let's get a common interface. Let's get the S&T guys and ladies plugged in to developing a common interface where each country might make a sensor that is for one part of space, say a cislunar sensor where you have a lot of protons, say a MEO sensor. Every country would have a sensor, and they just give them out. They only be a couple $100 made by commercial companies. And Admiral, the problem on this is who is a part of this allied radiation sensor project? I mean, I could see even some of our peer adversaries may want to be a part of this. And but the thing is, some countries, have a different space posture than we do. The UK has a lot of national technical means and not a lot of commercial. Australia is still building up commercial. They're still they're very busy doing some great work on that, but they're not in a position yet to say a lot of this national technical means data when they're still working out the blueprints. And so I guess I found myself trying to constrain this to a Five Eyes, but I'd very much like to include Germany, France, and Japan. And so that's how I see that, and I'll turn that back to you.
Yeah, super. If China applies, we should say no.
Well, it's like the the whole infrastructure argument, right? Yes, we have security, we have national security needs, but if you look at the ports of Long Beach and San Francisco, Oakland, where are all those ships coming from? They're coming from from China, and so they are a part of this whole process. And so how we incorporate that, this is a discussion that I've heard threads on for the past several weeks. But clearly, in the early stages for this radiation project, I think it'll be Five Eyes plus 3 is how I see it.
Super. Jason, any thoughts from a purely commercial perspective?
Sure. First of all, good to see you, General, and Barry. This is great to be on the panel with you. I really like what I'm hearing, and the thing that I would add is we've seen a lot of great results from partnerships. I'll just point to Barry, Lawrence Livermore, a national lab, DUI, government quick acquisition place, very similar to DARPA. They all use the same kind of cast a wide net, go work with commercial industry, labs, universities, looking for new sources of game-changing technologies. And then they fund it past a certain TRL level to get it past the valley of death. And then hence we get all these new capabilities that keeps us ahead of the curve. So we've seen partnerships work really well. I think we're seeing a similar thing in the global commercial space economy. And what we're seeing is we're seeing a lot of Five Eyes countries and other non-Five Eyes companies, investment companies investing in commercial capabilities, investing in proliferated constellations that provide new capabilities to do Earth observation. And what that's doing is it's giving the US government more competitive capabilities that can offer diversity in the types of Earth observation kind of collection capabilities that could help us with the future wars. And so I would say that it's the investment that I'm seeing. You look at Germany, Mynaric comes out of there. So a lot of the US companies can make use of their laser crosslinks. There's several Australian companies out there that are coming up with new technologies that we as US companies can take advantage of. Several UK companies that Barry was mentioning as well. So there's a lot of investment going on into commercial capabilities that we could use to help us. And there's also new capabilities, constellations of Earth observation that are going to come online that we in the US government can go subscribe to that data and help us get even more revisit times around the Earth to help us, to help us keep us safe.
Thanks, Jason. And gentlemen, we have about 10 minutes left. I've got two questions I'd like to ask the group, right? So short answers as we move along. If you could pick just one, right? Just one either platform or application in space for tomorrow's space needs, what would it be? We'll start with Jason. We'll go back around the horn.
Well, that's a curveball. I think that if I had to pick one game-changing new type of Earth observation constellation that we all could benefit from, I would say it would be hyperspectral imaging. That's an area that the Army could use more of, the Air Force, Space Force, intelligence community, everybody could use more of that because it's not the panchromatic EO imaging to resolve high resolution imagery to see what you're trying to go see. It really is kind of the fingerprint of what colors emanate from you or reflect off of you, and multiple colors in the hundreds of bands, right? So I think that's a very game-changing space-based platform that could revolutionize how we process the data turn it into information, share it among our coalition partners to help us fight the war and keep us safe.
Yeah, you're singing to me. From my days as a J2, I would often ask, well, what hyperspectral looks have we taken at this? What's the rest of the story? General, if you'd please.
Well, I like Jason's answer because it has so many applications. Hyperspectral imagery can apply from agriculture to defense to scientific research to sensors for a variety of different materials. So I do like that. I guess I would say the other element that I think is really critically important is a little more maybe governance, if you will, in space, because if any of you have looked at the latest picture of what's in orbit, you almost can't see an individual dot anymore. They've become so proliferated. So we have to have a set of standards that we operate with. Sort of rules of the road, I think, are very important. And then I think with that, communications really are the key to success for virtually everything we do. And so being able to put high quality, secure, if needed, communications aboard as many platforms as is possible. And then, of course, for my own self-interest, being able to downlink that data on the move to get it to the user most in need, I think is really, really critical.
Super. And Barry, your thought.
Well, I like Jason's hyperspectral so much, I'll take it one step further. I see obviously disaggregations of satellites into small constellations is obviously key. I mean, we have a CEO here who's working that heavily. With these downward pressures on satellites are for more power. So right now, we're simply doing detection, simply doing this single modalities. But in the future, characterization is somewhere we need to go. And so clearly in the future, to my mind, we're going to see optical and hyperspectral and synthetic aperture radar on a single platform that has, not a lot of ability to carry a lot of energy. We need that energy density. We're also, when you have those hyperspectrals and synthetic aperture radars to get a comprehensive picture of what's happening, you're also going to need to do onboard computing because those files are going to be too big to send off. So now you have edge computing. You have machine learning to make sense of it all. And so, to my mind, having these radiological materials and fusion and some fission thrown in there as power sources to power these intensive modalities that we need for sensing in the future, I think that platform would really help us go a long way towards, trying to get a better logistics in space and a better infrastructure setup.
Yeah, super answers all. And Barry, if you could start us off going the other way around, final question that I'll ask, and then we'll hopefully have time for a quick wrap up. What books or websites or podcasts would you recommend to someone who's interested in the future space needs, that they tune in on or read?
I like this better when Jason went first. Admiral, I would say the last few years I stopped reading so much and I just started going on the internet and looking what other companies and individual researchers are doing. Now, I think there's such a rich amount of information on a lot of these startup companies. A lot of these websites are very thoughtful. And I'm a big fan of where you live, sort of getting a feel for the space in your area. So the reason I have this horrible background behind me is you caught me in Houston. So I was in Houston this week. It's a beautiful city and beautiful weather this week. But I had to drop by my friends at Intuitive Machines and borrow some space to take this here. So I don't have much of a background. But take a look at where you are in the Houston area. It's a huge dynamic area. There's a lot happening in investment in space. Really, it's amazing here. And I know that there's other parts of the country. And if you just go online and look at these space companies around you to get a feel for all the really great, thoughtful, and creativity happening in space, to me, that's energizing. And it's really interesting. You might come across, Jason's company, if you're up in his neck of the woods over there, But I'm a big fan of just checking out what the space startups around you.
Fantastic. Thank you. General.
This is going to sound bad, but if you are sitting down to read a book about space innovation, you're 10 years behind. And that's the speed that we're seeing things develop in terms of machine-to-machine interface, of artificial intelligence, of miniaturization, and of almost microization of power sources. And so I'm with Barry. You really need to stay out at the leading edge of innovation. So the industry, I spend a little bit of time every day looking at just some of the various industry publications that are talking about startup companies that have a great idea, or the next turn for a satellite system operator, and from that I try to feed it back into the personal activities that I get involved with, both commercially and with defense, because I think that keeps you thinking about what could be possible. We don't yet have a good space strategy, and it needs to be one that's 15 years down the road. Where do we want to be? And I know General Raymond and the team are looking at that, but it's really a whole of nation space strategy. It's not just about the Department of Defense. And so I think we're going to have to inform that strategy with where we see the leading edge of innovation today.
Super. And Jason, bring it home.
So I've got a couple of ideas here. One is more the practical side. I still haven't read this book, but I plan to. It's called Kill Chain. So that's something that's on my list of books to read or put on audible.com, to the general's point. But the thing that I personally would recommend is just read a bunch of sci-fi books, because that's where your imagination just is unlocked. And a lot of the things that we do here at Millennium Space Systems, it really is like sci-fi, but we're doing it. And it's because we have a lot of creative engineers that come up with great ideas that no one else is thinking about. And there's other companies that do this too, not just us. But it probably goes back to the roots of people reading sci-fi books and books that are looking at the next 100 years or the next 1,000 years. And that's where it all starts. And so that's my recommendation, is read a lot of sci-fi books and get involved with national security space, and go out there and witness a launch and see these satellites turn on. It's really something to see.
Great. I use LinkedIn and Twitter as an indication and warning tool, for me that, okay, this prompted my interest. There's maybe a story, and I'll have to go onto the web and dig a little deeper to find the rest of the story, whether it's national security, functionally space, or any other topic, the way I set up a dashboard. And I think that's complementary, to the points that you made there. We have a minute or so left. Is there anything we haven't covered? General, start with you that you'd like to close with.
No, I think this was a great discussion, great panel. I think the entire day has been about innovation as we can carry our nation forward. I'm maybe a spoiler alert. I see Secretary England popped up on the icon here, so it's always great to I sit and listen to him close by. So he'll be a great closer, I think, if he's keeping you from dinner. I do think that that this discussion has to be often and vibrant, and we can't rest on our laurels, because we get behind the more we rest. And so I appreciate the team putting this together. I really enjoyed being with Barry and Jason and you, Paul, especially. It's good to have joint staff guys survive.
Thanks, General. Barry, any closing thoughts?
I would just say that, like in my experience, everything has a time life. Everything has funding, and then it doesn't have funding. Before this, I was leading up the nuclear weapons effects program at Lawrence Livermore Lab. In the 70s, it had a lot of funding, and then it didn't. Space has a lot of funding now. We have to be mindful that this isn't going to go on forever, that we need to really take the opportunity, start building infrastructure, start doing space logistics, OSAM, start getting things up there, leveraging these commercial money so that we can have a real successful outcome of this. And I think, I don't see this as as a thing that's going to happen next year, but not everything will last forever. So I'll just use that as my closing thoughts.
Thank you. And Jason, final word before we roll to Secretary England.
Thank you for this opportunity to share all this thought leadership. The thing I will leave everyone with is consider a career in national security space, and particularly in space. We in the U.S., we have a lot of capabilities across the nation. It'll take all 50 states, all these companies as well. And we're now going into a regime where we're building constellations of hundreds and thousands of small satellites now. And so that's going to take a lot of engineers, managers, administrative, security, folks from technician world. It's going to take a multidisciplinary team to make things go smoothly for the nation. So I encourage everybody in the audience to consider a career in space, and particularly national security space. Thank you.
All right, thank you, Jason. AFS Mothership, we'll turn it back over to you.
I guess that's us, is who he's talking about, the mothership, huh? Admiral Becker, we can't thank you enough, and certainly Gene and Jason and Barry. Well done. I mean, what a way to wrap up today, aside from, as you said, Secretary England coming up shortly. But that was great, gentlemen. We thank you so very, very much. Thanks for being a part of a very special team.
Thank
really.
you all.
Well done. Well done. Didn't you agree?
Absolutely.
Wasn't that great? Oh, good stuff.
You guys have a good evening. We appreciate you.
Yep.